Okay, Assalamualaikum. Today we're going to talk about how we can solve this problem. First of all, we need to highlight the information. Steam is to be condensed in the condenser of a steam power plant at a temperature of 50 degrees Celsius with cooling. Water from nearby lake which enter the tubes of the condenser at 18 degrees Celsius at a rate of 101 kg per second and leave at 27 degrees Celsius determine the rate of condensation of the steam in the condenser. Okay, so this is our questions, the steam and the condenser. Okay, next we will do the equations. We know this problem will be steady, then energy going inside is equal to energy going outside. Okay. Write the full equation where Q in plus W in plus M dot H1 equal to Q out plus W out plus M dot H2 out. Now we consider the potential energy is equal to 0 and the kinetic energy is equal to 0. So we don't need to write it again. Based on these cases, we will assume all the heat that energy that come out from the steam is directly 100% transferred into the tube. Okay, enough with the information. So now we can write the equation for both condenser and a tube so that we can solve this problem. Now we will focus on condenser first. We will rewrite the equation, then we will cancel out the variable so based on our information that we have. For this system, there is no work done or work by the system, so we will cancel out. We will also consider there is no heat energy going inside the system. Then we will simplify the equation. Next, we will focus on tube. So same as before, we will write the equations. Then we will cancel out the work where there is no work done or work by. Also, we will cancel out the heat energy going outside because there is no energy going outside the system. Then we simplify the equation. Okay, based on the information given, we already have the M dot, but we don't have the internal energy that going outside and internal energy that going inside the tube. So we know that this is the saturated water, so we can refer to table A4 to find the internal energy. Based on our information given, the temperature is going inside the tube is 18 and the temperature going outside the tube is 27. So we can refer to table A4 with information from 15 to 30. So when we get this information, we know that we need to do an interpolation to get the exact value of the internal energy for 18 degrees Celsius and the 27 degrees Celsius. To avoid the careless mistake, so we will rewrite the information given from the table into the new table that we will do it on ourselves. Okay, then we will write the interpolation equation for H3 to find the value of H3. Okay, the value of H3 is 75.5418 kilojoule per kilogram. Right after that, we will continue with calculation of interpolation for internal energy H4. So we write the interpolation equations, then we will solve the equation to find H4. H4 is 113.194 kilojoule per kilogram. With H3 and H4 that we get here, we can calculate the Q that going inside the tube. So we will substitute the value, then get the Q inside the tube is 3802.8722. We focus on the condenser equation where we can find the mass flow rate for the steam. So in order to get it, we must divide Q outside over H1 minus H2. To get the value of internal energy 1 and 2, we can get it from referring to the table A4. The temperature given for these cases is 50 degrees Celsius. They're going inside and outside. So we know that this is the gas and the liquid. So we can refer to the information from the table A4 that referring to the internal energy of saturated vapor and internal energy of the saturated liquid, which is with that value we can calculate the final answer, which is 1.5965 kilogram per second. Thank you for watching.